We're now going to sketch the solution to the system of inequalities. Starting with the first inequality, I'm going to plot our y-intercept, which is -3, and then I see the slope is a -1/2. I'm going to be going down 1 for every, it's a +2, so for every right 2 that I go. Down 1/2, and I will plot some points. I could also do the reverse, and I could say I'm going to go up 1 and back 2. That's going to give the same line. I still have a -1/2 as the slope. So up 1, back 2. It is an inequality, so I can't just dive in and connect these points. I need to be mindful of what kind of inequality it is, which it is greater than. It is not an or equal to, which means it is going to be a dashed line. That means the values on the line do not satisfy the inequality. And then I also need to determine shading. So I'm going to use the test point of the origin. It's not on the line of our inequality. So y and x are both going to be 0. So it will be 0 is greater than a -1/2 times 0 minus 3. So -1/2 times 0 is 0. And so I am checking to see, is 0 bigger than a -3? Yes, 0 is larger, greater than -3, which means our test point works. So I'm going to want to shade that side where the test point is. I'm just going to do those dashed lines. The solution to this system of inequalities is where both of our inequalities shaded areas are. So I can't stop. I need to move on and graph the second inequality, which I see we're going to start at a +1. And then we have a slope of 3/2. It's a +3 and a +2. So I'm going to go up 1, 2, 3, and over right 2. Up 1, 2, 3, and over 2. I could also go down 3 and back 2. When it's time for me to connect these points, being mindful of what is our inequality type, well, it is greater than or equal, which means I do have a solid line. The values on our line do work for this inequality. And again, test point of the origin, that is not on the inequality, so it would be a good test point to use. Of course, it is not required for you to use the origin. I like it as it removes other math that may need to be done. So 0 is greater than or equal to 3/2 times 0 plus 1. 0 is greater than or equal to 0 plus 1, and so we are determining, is 0 bigger than 1? No. Is 0 equal to 1? No. This is false, which means the inequality will not be shaded down there to the right side. Instead, it's going to go above. And so really, I'll use red. Red can show the true solution. The solution will be in red. And so that's where both of them are shaded. So we're above the blue line and on the left side of the green line. So anything in this area is going to be the acceptable solution for this system of inequalities. We're now going to be solving this system of inequalities. So starting off with y is greater than 3/2 x minus 2. Y-intercept is at -2. We have a +3/2, so I'm going to go up 3 and to the right 2. And I can also do the inverse, which means I'm going to go down 3 and back 2. And then it is greater than only, so it will be a dashed line. The values on this line do not work for the inequality. And then I need to do a test point. So let's try a test point of the origin. That is not on the line, so it's a great test point to try. 0 is greater than 3 halves times 0 minus 2. 3 halves times 0 is 0, so we have 0 is greater than a negative 2. That is true. Our test point works, so we will be shading to the left on that inequality. For our second inequality, we have y is less than or equal to negative x plus 3. I'm going to start off by plotting the y-intercept of 3, and then we have a negative x, which means we will go down 1 and right 1, and that can be done more than once to get multiple points for a line. We can also do the inverse, going up and back 1. All right, so this inequality is less than or equal, which means it does have a solid line. The values that are on the line will work in this inequality. But to know what way to shade, we don't want to use a point on the line. I think using the origin again as the test point could be a good idea. So I'm going to have 0 is less than or equal to a negative 0 plus 3. So is 0 less than or equal to a positive 3? That is true. 3 is not equal to 0, but 3 is bigger than 0. So the test point works, and so we would be shading below, but it will not be everything below the line. Instead, the solution, which would be any acceptable value that makes both of these inequalities true, would be the red shaded area, which is really below the blue line and left of the green line. So that would be everything in this area to the left. So this is where we actually have anything there works, and that's why I do not want to be very solid or covering up the graph when I am doing just the light line shading originally, because as we see up here, even though that works for the first inequality that I did in green, it doesn't work for the second inequality. Likewise, down here, that would be true for only the second inequality and not the first inequality. You have to be in the red area, the red shaded area, to get any values that would work out for both inequalities.